everybody. How are you? Nice to be here. Very excited to be here. My name's Daniel Frith. I think Laurie was calling me Firth. I think there's some confusion between Firth and Frith. But everyone knows who Colin Firth, the actor, is. No, it's fine, Laurie. Right, so I'm here to talk about democratizing 3D. I'm from Avataar. I'm the Vice President of 3D in Avataar. And I think this is a really important topic which we wanted to go into today because we've been at some presentations already today where we talk about how critical content is, 3D assets are for making different 3D products available. Because what this is fundamentally focusing on is how we go from 2D to 3D. We've done a lot of work in 2D in history for photographs. We take photographs of shoes, garments, products. That's how we sold our product to consumers who couldn't necessarily get to see a product physically. And there's been a lot of work that's gone on to get 2D into 3D. You know, a lot of people here have invested a lot of money into this. You know, but one of the problems with this flow is that it's not a very sustainable way of working. It's an expensive way of working. It's not very scalable. I'll get to the end of this part here and then I'll just talk about that because it's also time-consuming, expensive. It's not very scalable. It costs companies millions of dollars to build assets for their product library. If you take some big retailers, they have an enormous amount of product in their range. They try to digitize all of the content, and it costs a lot. And this is one of the reasons that a lot of companies invested into photogrammetry was because they tried to make it scalable. They tried to make it sustainable. So people invested a lot of money into building big rigs so they could take the back, break the back of the 3D content creation process, and they could take all of their product range and show it. The problem with this is photogrammetry by default is very complicated. Hands up who have worked in photogrammetry here. There you go. You see, there's a lot of people already working this. And they know, you will know how expensive this is, how complicated this can be. You can have small rigs or you can have big rigs. You know, so there's a hell of a lot of cost associated with this as well. You know, so you get a rig like this. We've got hundreds of cameras here. They're all probably $1,000 to $2,000 cameras. There's a lot of hardware, and you need a big space for this. I worked at a company. I've been at many companies where we've invested millions into this to try and democratize 3D content. And the problem is that when you spend all this money, you do all this, and you build all this hardware and software, you get results like this, right? So you try to build a coffee jug. It's a pretty simple thing. I mean, if people know 3D, they know that's quite straightforward to build in 3D. But, you know, when we're using photogrammetry, we're getting glass, transparencies, specularities. It's not really working out. It's quite complicated to do. Take something like this, you know, a simple camera. It's a very important product. You know, to see a camera from the back and the sides, especially if you're passionate about photography, you know, well, our photogrammetry output gives us products like this. Yes, we can refine it. Yes, we can spend time, but it's a very expensive and time-consuming way of working. And the problem with this is, even though I've written the word time up here, the reason I've written the word time is because we've invested all this money into photogrammetry to actually make the time process less. But it actually has often made it longer. Because if you take, say, a shoe, and you take the top of a shoe, the bottom of a shoe, you then have to run it through programs like ZBrush, you have to run it through other programs, you have to stitch it together, then you have to decomponentize it, you have to take elements out of it, just to get it to become usable in AR. So it's not very good on time. Quite a lot of the time. I mean, it can be good on some products, but in my own personal experience, you often have to spray things in a matte white to get rid of the specular problems. So you spend all this time and effort trying to get around this. So what I'm mostly here today is to talk about something quite disruptive and quite revolutionary, is how to remedy this problem. Because again, as we've already been through, it's cost a lot of money, and it's quite difficult and complicated to do. And this is where Neural Radiance Fields come in. Now, hands up who've worked in Neural Radiance Fields. Okay, 1, 2, 3. There you go. And it's quite interesting because it's been around for a while. We've been working in it for about 4 years. We've been developing it for quite some time. And the very interesting thing about this is that what this does, this makes that traditional photogrammetry work that we've done with those big, expensive rigs suddenly accessible on a mobile device. Now, we do also have some photogrammetry solutions and applications out there where we can use a mobile device to do photogrammetry. But what Neural Radiance Fields do is they take sign distance data, they'll read density of a product, they'll read RGB values of a product, and through something called a neural network, they will construct a product. What this is effectively doing is it's effectively building a two-dimensional / three-dimensional version of a product through data. But the smartest thing about this is all about artificial intelligence and machine learning. And I'll come into that in a second. Because one of the problems with photogrammetry that I talked about before is the specular problem. You saw the coffee jug, you saw the camera. What's beautiful about this technology is that we can fix a lot of this. Here's a handbag we were scanning in the office. And you can see there's a lot of specularity around this product. Yes, I've sped it up a little bit, but you get the point. But when you see this then transferred within about 20 minutes to a product like this, with no 3D creation, no work in here, it's just literally algorithms, code, machine learning, then bringing out a product like this. I will be honest, I will put my hands up, there's a little bit of noise in here, but this is the beautiful thing about AI and machine learning, which I'll come on to again in a minute. So the good thing about this is that, let's think of it from an end consumer perspective. I design this product, I make this product. To make this handbag in 3D and traditional methods, I don't know, day to 2 days to build it, get it signed off, quality controlled, 20 minutes. It's a big difference, big difference. Then also we can get to things like light fixing. Now, the reason this is in here is because one of the biggest problems in photogrammetry is creating a standardized, consistent environment. Because in order to create beautiful photogrammetry on a big rig, you need good lighting, you need a good setup, and you can't, as anybody who knows, has been who've worked in photogrammetry and still do work in photogrammetry, you can't touch that product, it can't be moved about. But if you look at the way the camera's moving here, it's shifting about all over the place. That product isn't stationary. The product is stationary itself, but the camera's bouncing all over the place. But the interesting thing here is there's different lighting conditions. So what we did when we were demonstrating this was we went from a standard lighting condition. You'll see it flicks to a darker one in a second. So what we were experimenting here is if I am photographing with a mobile device my product, and I've got it in a different variety of lighting conditions, when it goes through the AI algorithm and the machine learning, I can still get a consistent product out. I don't have to think, oh, that's too dark, or that's too light, it's too shaded on the back. We still get a really good product out of it. And if you think about it from an end consumer journey, from a customer hopefully buying this product, is this enough for a customer to engage in a product? We think it is. But the other big thing, as you've probably seen in these videos, is that the environment removal element is a really big thing. So again, not wishing to go backwards and forwards between photogrammetry and NeRF tech, but photogrammetry, you have to build this space. You build this safe environment. So we don't have to worry about the environmental removal. But what's beautiful about this tech is that background you can see there with the walls and the floor and the table and all the leads and the cabling and those cushions and all the other products we have in the background, just through the machine learning and the processing of that data, we can get it to look like this. And what's particularly interesting about this, of course, is that we haven't had to do any extra work to this. We haven't had to do any last-mile editing, and I'll come to that again in a bit. But what's beautiful about this is does this communicate the product enough to a customer? There are still some things we would like to do, things we'd like to improve on the specularity and the shining, but we can come to that as well in a moment. But the point being is that to communicate a product, to sell a product, to make a customer understand, or anybody understand what a product is, this is probably enough. And I think that's the big thing. To build a product like that in 3D is a lot of work. So there's a tricky balance, and we'll come to this again in a bit. So the other thing about this is not only have we got these assets on their own in a safe frame or a website or an app, but we're going to talk a little bit about implicit rendering. And what implicit rendering is a way of processing that data into making it a visual. You've already seen some of these visuals already. Now, to be really clear about NeRF tech versus photogrammetry, one of the big differences is, and I believe in being very transparent about this, is that actually implicit rendering is a stitching together of 2D images that you've taken with your camera, and that's combining it to make it look like a three-dimensional object, right? So it's kind of 2D on steroids, 2D.x or something like that. But the point being is that what you're seeing here is the evolution of 2D photography. You're seeing the evolution of 2D images in a traditional way being handed to consumers who are now interacting with products on different devices. Augmented reality, web browsers. 3D is now in the hands of the many. 3D is now something that everybody has access to. And if we then, I don't know if anybody's had to make a product like that in 3D, with doing fur and hair and things like that. It's a very, very complicated task. It's something that generally 3D artists avoid if they can, because it's a pain and, yeah, I won't swear. The point being is that when you take that implicit render out, and even though we're just placing it on a table and there's no shadow, but you get the point, is that all the hair and the definition and the density of the product is still being shown. For a child, for an adult, I can get a sense of what color the ribbon is, you know, what density the hair is, how, because of those things I've shown you before of the specular and lighting removal, we don't have that issue of, you know, when we do renders of light and hair and everything, it's very complicated. And again, this is a same time as it was when we've had to produce the handbag or the jewelry. And I think that's a really interesting point to bring up, is that in 3D content creation, traditional methods with 3D tools like Max, Maya, Blender, whatever, if you ask a 3D artist to make that, it's going to take them, they'll go, 3-4 days. But if I ask them to make a mug, they'll go, yeah, a couple of hours. But with this tech, it doesn't matter what the density or the complexity of the product is, because you're still getting the same product out. But I think what this brings up is a really important point of what the AI is doing is it's taking a neural network and it's learning. So even though there have been some pictures here that have a little bit of noise in, we're seeing changes in that tech so that it's learning. So every time it's processing a chair leg, it knows next time I've got a chair leg this big, I don't have to work on this. When I'm processing the floor of a certain environment, it says, okay, I've learned from that. So the point is the AI and machine learning is always working, it's always learning, and it makes the processing quicker. When we first started to really develop this, the times to go from photographs, or even just a few photographs, to the implicit render was a lot longer than it is now. Now we're down to 15 minutes, and our intention is to get down to 10, even under. So you, anybody with a mobile device on any device, can hopefully go around and just walk around this bottle, around this microphone, and then get your asset and your product available to anybody to interact with. And that's a big thing. But there is another element to this as well, and I'm just conscious of time, that there is a, even though it's a combination of 2D images to make the implicit render, there's a very important point of photogrammetry creates 3D. What this tech can also do is create 3D as well. So what I'm going to show you now is a scan, like you saw in the others, where we've done the same tech, we've walked around, we've taken some photos, and we get a 3D model out. Now, it's effectively in two parallel flows. There's an implicit render and there's a mesh flow. Well, what's really interesting about this, anybody who works in 3D will be able to tell you that the geometry flow is good, the topology flow is good, the lines and the edges move well. It's not a complete mess, which it often is in photogrammetry. So we can get around that a lot by doing this. because the way it processes the density of the data is really good. But there is also an element missing to this, which is in order to get this is quite a high density mesh, as I'm sure many of you will know. But the interesting thing here is just with a small piece of last mile editing, we can go from taking a mesh that dense, and because the quality of the product was so good in the first place, building levels of detail through automation is very straightforward. Applying then materials, shaders like substance shaders or anything else to a product. This is a 3D model, not an implicit render. This is being shown as a GLB. So the point is, it's taking that data, we can build levels of detail through automation, and then we can put shaders, and we can get to that 3D content way of working. I think the reason I wanted to bring this up was not just because, sorry, my throat. It's not just because it's, sorry, a bit of a cold. It's not just because there's a people point to this. Because, oh, sorry. Oh, that was loud. Sorry. Oh, God. Sorry, as my throat's packed in. Great. Now's not the time to do that. The point is that, wow. Sorry. 1 minute. Wow, it just completely packed in. Right. There's a human point to this. If you automate 3D creation, there are millions of 3D artists in the world who do this for their job. And that's something very close to my heart. I've worked in 3D for nearly 30 years. And when I came across this wonderful technology with these wonderful people, I realized that I was seeing the future of 3D content creation. And of course, I start to think about the people equation into this, because there's people who've trained for years into doing this. But the whole point of doing photogrammetry was to streamline this. So how do we embrace this? How do we become part of this? And I think what was interesting about that thinking was, if this tech can take the legwork and the back and break the back of the monotonous 3D work, dare I say, it's not great for any 3D artist to build a sideboard of a bed, you know, over and over and over and over and over and over. It gets very monotonous, right? But if this can take the back out of that and do 70, 80% of the work for you, then hey, I can be creative. I can be in that creative flow at the very end there. And that's a really good thing for an artist, because what all artists want to do is be creatives, not want to be pushing polys around over and over and over. And if that can help by building it like this, that's a huge thing. So the point being, is with this technology, it does make 3D content creation sustainable. It makes it a lot more efficient. But it also makes it scalable, because we can now handle as much volume as anybody can basically use their camera. So rather than thinking I've got to build a big schedule, a big plan, a big project plan of building a load of assets, I can basically take these photographs. So this also helps us with the quality, cost, and time point, because we're talking much less time. Maybe we can take a lot of the legwork out of it from a 3D content production perspective, but also we can still get the quality, and maybe even get better quality, because you can still get photoreal quality. I don't know how many times I've had to sit and make things like handbags myself in the past and get feedback and tweak, feedback and tweak, feedback and tweak, right? Over and over and over. And that can be demoralizing for a 3D person, because especially if you're feeling, I'm a frustrated creative. But then with this tech, especially on the implicit part, I get a true representation of the product every time. But I guess my last point was that if you look at where we've been with 2D, and then when we look where we are with implicit rendering and photogrammetry, and then also how we go to meshes, what works best for us is a question only you can answer. Because maybe a 2D photograph of a kid's t-shirt is enough to sell a product. I know I've worked with companies like that before, and that's not enough to sell a product. So they want to go into 3D. So they're investing millions. And I think there are a lot of 3D products out there, like AR solutions. You know, we've seen some great stuff on spectacles today. We've seen all this different technology and hardware. But it's the content part that's the pain. It's the content part that's the backbone of it, because products and 3D content are irrelevant without each other. There's no point in having an AR platform without something to show. but there's no point in having 3D content without anywhere to show it. So you have to ask yourself, do I have enough from an implicit render to show a consumer all the sides of a product? I would say probably yes. Or do we need to go some last mile editing on the mesh part so that we can do that final tweaking? One thing that Implicit and NeRF can't do at the moment, and we're looking at it, is animating. Taking a chair that folds out, folds back, fridges that open and close. You need some mesh work there. You need some 3D work there. And I think that's the important point about that. So what is your need? Where are you? What do you need to do with this? So I think that's something that we're looking at. We spent many years working on this, and we feel that with this method and with this content creation way of getting 3D assets out, that we are, I don't know, it feels like quite disruptive. I feel a bit bad about it sometimes because I've been working 3D for a long time, but I think this is the future, and the problem with 3D is it's not scalable. So that's it. Thank you. Yes.
Questions?
Leonard.
Of course. So I've seen this work in a number of different situations, and it's really absolutely fantastic for products that exist or anything that exists.
Yeah.
But a lot of whole production schemes are going to where the product starts as a CAD model.
Yes.
And moves all the way through, and so you don't actually see anything to take a picture of until you're essentially done. How does that change what you're pushing here?
That's a great question. And I would expect nothing better than from you. I think what we need to do, and at the moment what you're seeing is the end customer journey. You're seeing a product that's to sell a product, right? You're seeing a 3D assets used to sell a product. So what we need to look at is how do we take this tech and maybe make some flexibility? How do we scale things up? How do we get it involved in the product development process? It could, of course, oh, that's my throat again. Sorry, Leonard. We could, of course, use this tech to expand that possibility. Oh, thank you. A sweet. How cute's that? Thank you. But I think that's something we have to look into. What I've demoed today is the customer experience. And I think in order to do a full end-to-end solution with this, you have to look into how you can actually allow designers to customize and modify products. So I don't know if that answers your question. Thanks, man. Hello. Sorry.
Is there like an iPhone app, an Android app?
Yeah, so we've developed a mobile app. It's accessible. We're at booth 324, which is open tomorrow. So please come by and talk to us in more detail about how you get access to that app and how you get access to it. It's effectively almost free. So we are not well, come and talk to us about it and go into more detail. But it's basically downloading the app and you can then scan and then you can get your content out. So.
Another question?
Yeah. Oh, sorry. Wow.
Hi. Just wondering, which industries have you noticed being most receptive to adopting this technology? And have you seen anything in the consumer area, anything interesting that surprised you in terms of use cases?
We know that there's a lot of interest in it from retail space, of course, because the idea is a large turnover of product, right? So if you think about footwear manufacturers or apparel manufacturers, this could be a huge benefit to them because it's a very complicated and time-consuming process. So if you can use this to streamline that and make it more scalable, then that's great. We also see a lot of possibilities for it in things like the VFX industry or CG industry. Because rather than building hugely complicated sets in CG, directors could take photos and videos of what they want and then get the assets made, and they could even build sets straight out from it rather than... So there's a lot of use cases for it. There's a lot of use cases in automotive, there's a lot of use cases in different industries, which is really good. Yes?
Hi. I think this was very exciting to see how products were getting converted to 3D. My question is, so I'm running a AR tech company for fashion,
Yep.
primarily jewelry. That's what we started with. We are currently at around 200,000 inventory,
Wow.
which has been digitized and ready to use in AR.
Yeah.
We do about 1 million try-ons a month, right? My question is, and you rightly said that 2D versus 3D, and 2D is obviously a little static. And now when we move to 3D, the pain is there. I mean, every 3D asset needs to be converted. So here what you showed was real inventory being transferred to 3D.
Yep.
We are working with global brands, right? How do we convert, is there a way that you have where images on the web can be converted into 3D in a click, the way you've shown here?
Yes, in answer to your question. I mean, if it's one photo at one angle, maybe it's slightly more complicated, but it doesn't have to be more than 4 pictures. Quite often, a lot of inventory on websites, you've got angles from one left, from front and side, and different angles, and that's actually enough for us to process this and build something that you can spin around, because the AI and machine learning can basically average that out. We've done some tests where we've got products that we've only got 2 or 3 photos on, and it can do the backs, it can do the tops, it can do the sides, it can do other parts that we have no information on. And of course, the beauty of it is, because it's quick, it's easy. Sorry, that's that whole suite I've now got. You can easily experiment with it as well. So if you need more data because it's not quite getting the product right, then even just a couple more photos will be enough. Of course. Please. Oh, that's me done then. Thank you, Laurie. Thank you, everybody. Thanks a lot.